Hello, my name is Dan Grazier, and I'm a technical marketing engineer with Cisco's Data Center Product Group. This video is part of a series that is intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Computing System, or UCS for short. In this video, we'll discuss the role UCS plays in FlexPod, an industry-leading integrated infrastructure. By now, many of you are probably familiar with some of the benefits and value proposition of integrated infrastructure as a whole. The idea that we can take networking, compute, and storage elements, pre-test them, pre-configure, packaging those together, and deliver those as one unified solution into a data center, making it easy to set up, deploy, and maintain on an ongoing basis. So what sets the FlexPod integrated infrastructure apart? Well, first of all, it's based around all best-of-breed infrastructure. Cisco Nexus switches for networking, Cisco UCS servers, and NetApp fast storage. And all three of these components can be managed from one management tool, UCS Director, that also integrates up into the hypervisor level with VMware and Microsoft Hyper-V. In this presentation, we're going to focus in on the value that UCS servers bring to the FlexPod. And of course, any integrated infrastructure is only as good as the underlying architectural foundation it's built on. One of the advances that UCS really brought to server architectures was this idea that it abstracts out the networking and management portions of a chassis up into these fabric interconnects. You can see these are then connected to a chassis, and really each chassis then just serves as a way of adding additional servers. There's not a lot of intelligence in each chassis. So whereas legacy architectures required you to have additional switching and management hardware for each chassis that you added, and encouraged kind of a mindset of thinking of each chassis as an island by itself, given that you had to configure and set it up individually. With UCS, you really have sort of a large virtual chassis where everything connected to that fabric, that pair of fabric interconnects, functions as one large virtual domain. And so you can see, when you think of it that way, that whether or not we have two chassis under a pair of fabric interconnects or, say, 6 chassis under a pair of fabric interconnects, it really doesn't matter. It's a very scalable architecture. Another advantage of this change was the ability to have high availability right out of the box. And this comes because you can see that network connects from each pair of fabric interconnects into the chassis. And if one fabric interconnect fails, all the traffic that would be going through that fabric interconnect fails over automatically to the other fabric interconnect without there needing to be any human interaction whatsoever, and no need to configure anything like OS-based NIC teaming, for example. Another advantage is that the management, UCS Manager, is actually living and running embedded on one of these fabric interconnects. And UCS Manager runs on one fabric interconnect active and passive on the other one. And so if the active one fails, it transitions again seamlessly over to the other one, and that becomes the active copy of UCS Manager. So again, transparent, no need for any action on the part of the user. And then probably the other really large advantage that we see with UCS was the concept of stateless profiles. And you hear a lot these days about the software-defined data center. And what does that mean, really? Well, here's an instance where we use software, a service profile defined in UCS Manager, to really give a personality to each server. So, you can take that service profile, define UUIDs, connectivity settings, firmware revisions that are correct for that type of server, and apply that profile to a server and get it set up exactly the way you want it automatically. And because UCS Manager lives on that fabric interconnect, it can even detect when a new blade is inserted into a chassis. And if you have policies configured beforehand where that server matches to one of those policies, it will automatically place the correct source profile onto that server once it detects it coming in. So again, no manual intervention required. These benefits of templates and policies, high availability, and scalability obviously all extend up to the FlexPod as well. And in terms of scalability, even allow us to go all the way to 160 blades under one pair of fabric interconnects or one domain. And that can be 160 rack or blade servers. So a tremendous advantage compared to competing integrated infrastructures. Let's look at how bandwidth connectivity between the fabric interconnects and the chassis works. And one of the great things about UCS is it really allows you to select the right amount based on the needs of the applications you're running. So you can see here, if we want to connect and just have 20 gigs to the chassis, then we just run two 10 gig connections between the fabric interconnects and a chassis. And we can scale all the way from there up to 16 connections between the fabric interconnects and the chassis, giving us 160 gigs of bandwidth into the chassis. And another thing here is obviously this gives you a lot of flexibility at the beginning to define exactly the right amount of bandwidth you want to have available. But sometimes you may not be able to exactly predict, or you may want to change what you're running on your setup. So you've owned your FlexPod for a year, and you want to change some of the bandwidth connectivity you have going to a chassis or multiple chassis. Easy enough. All you have to do is run additional connections between the fabric interconnect and the chassis, and it's very simple to go from 20 gigs to 40 gigs. So let's contrast that flexibility of the underlying UCS architecture to what happens with competitors' legacy architectures. You can see in the picture here, obviously, as we've talked about already, there's going to be 2 management boards on each chassis. There's going to be at least 2 switches in every chassis. All those things are going to be duplicated every time you have a chassis, so that's additional hardware you have to purchase, additional hardware that has to be set up and configured and maintained going forward. And obviously it results in an additional complexity for cabling. So let's look at how that feeds up into some integrated infrastructures. Talking about the HP Converged System 700X. The 700X is HP's largest converged system. And at its largest scale, it can hold 4 HP C7000 chassis or 64 blades. And when you do that, when you have those 4 chassis, you're going to have 2 virtual connect switches at least in every chassis. So that's 8 switches. You'll have 4 top-of-rack networking switches, 2 top-of-rack management switches, and 2 top-of-rack fiber channel switches for a total of 16 switches. Now you may say, okay, that's fine. That's all I'm going to need. But what happens if you do have a need that goes beyond that, and you need to buy another and set up and configure another Converged System 700X? You're going to start duplicating that same array of top-of-rack switches and, of course, in-chassis switches every time you have an additional Converged System 700X. And let's look at the PureFlex as well. PureFlex was IBM and is now the x86 version of the PureFlex will be provided by Lenovo. It has a maximum configuration size of 3 chassis, which is a max of 41 blades. It's 42 blade slots, but one is taken by the Flex System Manager device. And so same thing with 3 chassis there, you're going to have 6 switches in the chassis, and you're going to have 2 top-of-rack networking switches, 2 management switches, 2 fiber channel switches. So you're going to end up with at least 12 switches for 41 blades. So each of these things are going to be very complicated at scale, a lot of cabling, a lot of hardware points that need to be, additionally bought, of course, and then also managed. And lastly, for the PureFlex, it doesn't even have a capability where if you have to go to multiple PureFlexes, there's no management tool that can span multiple PureFlexes. The Flex System Manager is only good for one PureFlex. A second PureFlex will have a separate manager with no ability to do global policies, unlike the UCS management. So you can see that unlike competitors, complex integrated infrastructures that have difficulty scaling, FlexPod is based on a very flexible and reliable UCS architecture. So to recap, complexity in setup, deployment, and ongoing management can be a challenge in many data centers, and FlexPod addresses those concerns by combining best-of-breed components into a pre-tested bundle built on the flexible and reliable foundation of UCS. This ends this UCS Advantage video. where we show how unique capabilities in Cisco UCS can lead to simplified deployment models with much faster service turnaround to meet the increasing demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown in this video. Thank you.